Hello, everybody, and welcome to Designing a Combinator Library in C#. My name is Philip Fusich, and this is a talk I gave at my work to our development staff. And since I did it all in my own time, I decided to make a video. So hopefully you will get a lot out of it and it will inspire you. So a Combinator library is just a fancy term for a library that is predominantly made of functions, and these functions are created in such a way that you can combine them together. They're functions where their parameters may take other functions, and the function itself may return a function. This is a functional programming topic, but I promise you it's not going to be very complicated. So we're not talking math, and we're not going to do parsers. This is going to be about management information systems. So it will be, I think, applicable to a pretty wide audience. If you're familiar with C#, you're probably familiar with Microsoft's Language Integrated Query, which is in the system.link namespace. That is a functional Combinator library that is used by many programmers to deal with sets, collections of things in C# that you want to iterate over, filter through, and select pieces out of it, select objects out of a collection, much like the way you would select records from a database. We're going to talk about why you would create a Combinator library yourself and what bang for the buck are you going to get out of this? What's the payoff for it? And hopefully the examples will show that, and they're going to be on my GitHub repo, which I'll put in the links below. So the purpose of creating a Combinator library is that when we do it and we do it right, we should be able to use that Combinator library for additional development where we're going to increase the speed and the clarity and the correctness of what we write, reduce cut and paste, and we want to make sure that we make the library so that it's super easy to use, that it takes care of our best practices, and you'll see this in the example code. And I think that one of the libraries I have here will show that it will also help us support dynamic systems. And by dynamic systems, I mean systems where some of the functionality may be defined actually by a user maybe, or we may have some configurations we can send out over time that allow the functionality of the system to change without changing code. So hopefully the examples will show some of that. So one thing that's pretty fascinating about these Combinator libraries is that when you use them, it looks like you're typing out essentially like a sentence that describes what you want done by the computer, instead of writing in traditional imperative if then else type code, which means that the Combinator library forms a miniature domain specific language, or a DSL. So when we design a library, we have to think about the domain of the problem we're trying to solve, and we need to be careful in keeping the words appropriate for that domain. We're going to talk about two different styles of Combinator libraries. One is a library where you're writing your code and it goes directly into logic. And the indirect kind is I'll be writing some code, but that code will go to data first, and that data can be saved. And we're going to use JSON as our intermediate format, our data format. But you write your code that solves a particular problem. The library turns that into data first, and then at some future point in time, you can turn that data into logic through another function. So we have some design goals that we're going to try to adhere to when we design a Combinator library. What we want to do is we want to make it so that a developer sitting in front of the computer with Visual Studio in front of them, that it is super easy for them to remember how to get started using the library. And we're going to use as much of Visual Studio's IntelliSense capabilities as possible to make it so that the developer almost has nothing they have to remember in order to correctly use the library and to get the computer to do exactly what they want. So our first example of a Combinator library is going to be working with data from a database. We're going to pretend that we have some light database work to do. We don't want to go and use Entity Framework for it. We just need to query out some values out of several tables in a database. And we're just using the system.data namespace, the system.data.sql client namespace. And we want to make doing that work super easy, super fast. So if you've ever done any database work, this code might look a little bit familiar to you. I'll just explain it real quick. Essentially, we are opening a connection to a SQL Server database, and we are creating a command, setting it up. We're creating a reader to read data. And based on the fact that I've got this reader next result, we imagine the query actually has two select statements in it. And it is reading one record from the first select and 0, 1 or more records from the second select, and it's essentially turning the data from the return from the database into an object, and it's adding some detail records into that object, and it's doing some cleanup stuff, and it's sending out that last order object. So I'm using this example to show you that really what we're trying to do here with a Combinator library is we're going to address some things. We're going to build in best practices. The SQL connection, the command, and the readers all are disposable objects, so you need to use using on them. That's kind of a best practice. We're going to encode that into the library. This I call this ceremony, things that have to be done every time you want to use this API, and there's a lot of just stuff you just have to write. We're going to build this in and try to eliminate as much of the ceremony as possible. And then there's things like clutter. Essentially, all these squirrely brace, I haven't even highlighted all of them, but we're going to try to eliminate all that curly brace stuff and try to reduce the clutter. Vigorous writing is concise. A sentence should contain no unnecessary words. A paragraph, no unnecessary sentences. For the same reason that a drawing should have no unnecessary lines, and a machine no unnecessary parts. This requires not that the writer make all sentences short, or avoid all detail, and treat subjects only in outline, but that every word tell. The great thing about this quote from William Strunk Jr. is that he's advocating for something, and he's showing you in his own writing exactly what he's advocating for. With this in mind, let's take a look at the Combinator library that will address our database problem. Okay, so here's our demo solution in Visual Studio. There are two projects in here. This NISA data client is the actual Combinator library, and then we have a console app which uses that library, and it has several little classes in here. The order and order details classes are really my C# representations of the data that's coming out of a database. And we have a program. This is the actual static main that runs the program. Essentially, it's just running two different get most recent order functions, which return an order object, and then it goes into this output results, and that displays it to the console. And essentially, so what this thing does is essentially it does a call in our before class, which is essentially us not using the Combinator library, and then it does the same call again in a class where we're actually using the Combinator library, so you can get a sense of the difference between the two. Unfortunately, I'm not on a machine that has SQL Server, so I can't run this, but I don't think that's important. I think what's important here is the code itself. So that said, let's take a look at the before real quick. The before is pretty much what I showed in the slide presentation. This is essentially reading through, constructing an order object from the first query in our SQL statement, and then constructing a set of order detail records from the second query, and then putting them together using this with last details method on the order object to combine the two. So essentially then that returns the last order after the cleanup. So that is us using simply system data and system data SQL client to get out the last order out of the North Winds orders table and order detail table. So how would this look using our Combinator library? So what I've chosen to do here is not show the actual code. What I'm going to do is I'm going to type the code so you can see exactly how this works. The idea here is I want a developer to come to the library and with maybe a single word, they would remember exactly how to start working with this library. I chose the word with. You can use SQL or whatever keyword that you like, but I wanted almost everything to be prompted by Visual Studio's Intelligent Sense. So I would say with a row, and that's going to be the first row in that select statement above. And it is going to be of int 32. That's the first column. The second one is a string, and then of a date time. So with that row, I need to make, and now you can see by the prompting in the IntelliSense here, what this wants is it wants a function, a lambda expression, that is an int, a string, and a date time. And what are we doing with that? Well, we're going to do a new order. And the order ID is not nullable. That column will not be nullable. So what I do is I just essentially get rid of the null part of that. And then we have the recipient, or the ship name, the recipient. And then we have the date, the order date, and that is nullable coming out of the database. So we can just use it just like that. So that's what we make from one of the rows. And then what we want to do is actually tell the API, what are we going to do? Read one object or multiple objects? As you can see there, we're going to just do read one object. Now, this isn't the end of it. Oh, I'm sorry. You can see I'm missing something on the order. And I know that what that is it's the constructor takes details. So I need to just say, well, we don't have the details yet. Let's put null in there. Okay. So we don't just have one object, we have another read we're going to do, so that I have that encoded as a then. We're going to, with another row, which is the ID, of it, int 32. I know the type of that is int 32. And then the product name, which is a string. And the quantity, I know that that is int 16. And the unit price is a decimal of decimal. So with that, we're going to make, and here we have the same lambda that it needs, but we have 4 different columns, and we're going to do a new order detail. And again, the product ID is not nullable, so it won't come out of the database null, so we just get rid of that nullable property. But the quantity is nullable and the price is nullable. So that takes care of making the detail record. And then of course here we're going to read objects. Now the then function needs another function to tell us how do we put together the object that it read before and then this set of objects. So you can see by the IntelliSense here that what it's prompting us for is another lambda function that takes an order and some set of details, and we'll transform this into something else. So what we're saying is take the order and use the with details method to give it the details, and that's what we want out of that. Then, of course, we still have to tell it what the query is. So for, you can see for query as a method I now have available to me. Put the query in there. And there are some optional parameters on there. I don't need to put those on. I'm just going to take the default behavior. And we want to execute that somewhere. So we'll use the ExecuteOn method, and that's connection string. Now, we still have one small problem with this. The final method there, ExecuteOn, is returning a function that returns an order. You can see by the IntelliSense there. It's pretty, hopefully that's not too small to read. So we really actually have to execute the function, and that should make everything all right. So this is using the Combinator library. Essentially, all of this code is happening behind this code. But this code here really just represents specifically what is different from one query to the next, or from one specific instance of me going to the database and getting something to a different one where I need to get something completely different. So what I'm going to show here is I'm going to F12, go to the definition of ExecuteOn. And you can see that really the ExecuteOn is essentially nothing more than the using connection part of my before. Look at the before here. Using connection, open, then do something, then close it and return something. And that is essentially what this is. So it takes a function that takes a SQL connection and returns some type T, that it calls that the query, and it's essentially a connection string as the other parameter that it takes. It does everything, runs the query to get the result, does the cleanup, and returns the result. So you can see here that what we've done is we've encoded the best practice of the using, the ceremony around the using, and the connection setup and closing. And we've essentially baked that into this extensible function. So one thing that you can do here too is you can look at, well, if this function takes this type of function and returns a function that returns T, then what can go into this? And what I'm going to do is do a find on that. So we can look for everywhere up here that that returns that kind of function. So for query is a specific function that returns that type of function. So this, the result of for query can go into ExecuteOn, and that's exactly what we saw in our after. The result of for query can go into ExecuteOn, and that's why IntelliSense happens there, because once I get this function result out of for query, it automatically prompts me for, well, you can put ExecuteOn on that. And then for query takes functions that take a SQL result reader, and it wraps them with the actual create command, and it does the reader part of it. So you can see there's then goes into that, and read objects, read records. I've got essentially what I've done here is I've got different functions for representing tuples or structs, as opposed to representing things that are actually going to return classes. In our example, we had everything we created was returning actual classes, not structs, but the library allows for that. So those things, those are functions in the Combinator library that can then feed into the then, which combines two different object reading or value reading type functions into a single combined read, and then that can go into for query. So you can look at this all you want by going to the GitHub repo where I've got this, and you can take a look at all of the scaffolding code and the code that makes this work. It's not super big, but there are a couple little things in here that are little tidbits that make things work, like this delegate and my of class and the width and this craziness you can take a look at. But essentially, this was the way I made the Combinator library do all of that prompting that hopefully gets a developer up to speed much quicker than having to remember everything they have to do when they write something like this from scratch. This next Combinator library is about scheduling. Specifically, we're limiting it to how to define dates that are not available. Of course, we're talking about holidays and weekends. In applications that have scheduling functionality, we shouldn't force a user to tell us year after year what days are the holidays. And ultimately, we shouldn't hard code those rules in code either. So what we want is a rule that will work year after year that's not hard coded. And so we need a data layer between the definition of the holiday rule and the logic of that rule. Here we have the scheduling solution. So it has 4 projects in it. This Nissa Logics is some standard functional programming type logic that's required by the other ones. The Combinator library itself is inside this scheduling project, but also inside here is the classes which make up the static form of the rules. So these are just simple classes which encode or and what day you're talking about of the month, or what month of the year you're talking about. So when you define a rule, its intermediate form will be in a set of these objects. And then we have some JSON serialization and deserialization logic here in the library. Then there's also the logic transformation. This is the actual Combinator library, which takes a rule structure and turns it into a date function. So let's take a real quick look at the testing library here. We have a testing project as well as this rule visualizing object. This one here is a WPF project which can show us the rules when we run them and want to display them on a calendar. So let's look at what you would do to define rules. The rules are defined using a tuple which gives us a name and a category. So here we can see New Year's Day is really a combination of 2 rules where we're saying normal New Year's Day is in the first month of the year, the first day of the year, and when it's not a Saturday or Sunday. We observe it if it's January 1st, but the month is January and the day is the 2nd, but that's a Monday because the 1st actually fell then on a Sunday. Otherwise, if it's in December and it's the last day of the month and that happens to be a Friday, that's when we're going to observe it because it means that the 1st of the year fell on Saturday. So this is pretty straightforward stuff here. It's a set of extension methods, and the output of all of these rules are, you can see they're classes, not functions. So this is defining all the different standard holidays, standard United States holidays. And then what I do is I create an array of these, and then we turn that into JSON using this extension method and save that out to this file. I can show you what that file looks like. I've actually saved it here under this project. So this is it. It's not unformatted JSON, which essentially shows all those rules saved to data. And I've done logic where I've taken those rules and stuck them into a database table in a SQL Server instance and then pulled them out and run them. But what we're doing here in this test is we're essentially saving it out, reading it back in, and turning it back into from JSON string into the actual objects again. So I end up with rules and rules clone, and then I turn that into logic. This extension method takes an IEnumerable or a collection of rules and turns it into a function which will return to you. It takes a date and returns whether or not that date matches a rule by giving you the rule that it matches on. So I've done that with both the original and the clone, and then we run through a whole bunch of dates and make sure that each side of this comes out with the same results. Pretty simple. The visualizer simply reads in the rules, and this obviously this could come from a database, but I'm having it read it right out of a file, turns that into the objects, and then we create a view that is a selector that allows the user to select which rules they want to apply. And then this thing is basically refreshed. This is what gets refreshed every time I select a rule. So we take the rules that are selected and we turn that into an array, and then we use the same toLogic to say, for every rule that you've selected, I'm going to create a function that is a combination of all those rules. So you can give me a date. With this function here, you can take a date and you can see whether it matches any of the rules. So let's run this so you can see what the output is like. So this is pretty down and dirty. I'm essentially generating a calendar on the fly. Nothing is bound dynamically. Every time I hit one of these, it's going to regenerate this entire 5-year calendar. So it's a little clunky, but you can see I'm going to apply weekend, New Year's, President's, Memorial, Thanksgiving, day after Thanksgiving. So I can select which rules, and every time it does that, it creates a new function which combines the rules that I've selected, and it recreates this entire calendar, putting in the dates and also colorizing which rule has applied on that date, if any. And you can see here for like 2017, we have New Year's on the 2nd. So that's essentially the functionality, and you can go through that, get that the entire solution off of GitHub and test it out for yourself. But the point here is that eventually I might want to be able to create a client-oriented tool where they could go in and define the rules themselves using some forms, and they could say, well, I want to come up with a new holiday, and I'm not a programmer, so I want to do it through a UI, and I would take that and save that and apply that along with other standard rules that maybe come with the system. So that's the idea here. I'd like to close this talk with a couple of small points. One of them is kind of a challenge to the C# community. When I went into GitHub some months back and I did a search for Combinator library, I was hoping to see some examples of different kinds of Combinator libraries that solve different problems. Essentially what I got back was a whole lot of repos dealing with parsing. There was some on combinatorics, which is mathematics, which is fine, but I didn't really see much else. It was pretty much parsing and combinatorics. And I think that obviously there might be some repos out there where they just didn't put Combinator library in the description of it, and so that didn't come back. But I kind of think mainly that isn't the case. I think mainly C# developers are object-oriented programmers, and there's nothing wrong with object-oriented programming, but there is no doubt that functional programming and Combinator libraries are really, really powerful. I know a lot of developers that love LINQ, Microsoft Language Integrated Query, and that is definitely a functional programming combinatory library, a Combinator library, and there's many developers they would essentially stop programming if they didn't have LINQ. It makes that much of a difference in their day-to-day work. So I think we need to start thinking in the C# world about how we can use functional programming and combinator libraries to solve all kinds of problems and add to the power and expressiveness of the language. Because really, when you create a combinator library, essentially you're adding a mini language inside C# that allows you to express yourself in a specific domain in a very terse way, that's easy to understand, and it's less prone to error, and it encapsulates all of your best practices. My second point is revolves around this quote that I found by Lawrence Krubner, and hopefully I'm pronouncing that correctly. I found it online, and it seems to me to be so true. At least this has been my experience. When I try to do everything with OOP, with object-oriented programming, I find that when I start to get into more complicated things, especially dealing with functionality that I'm trying to make dynamic, I tend to find that if I'm trying to do everything with OOP, I just can't quite express what I want to express with it, and I end up with all kinds of crazy class names like providers and proxies and agents and all of these weird names that kind of don't mean anything, and they don't get me what I want. I feel like, what's wrong? Why isn't this expressing what I want to express, and why is it so hard for me to to create this dynamic piece of functionality? So I just love this quote. I think it's dead on. So I think that C# programmers really need to think through their total allegiance to OP, and they need to start thinking, well, I need to know more than just OP. I need to understand functional programming as well. Okay, that's all I've got. Thanks for watching, and feel free to download the code out of GitHub. The links are below, and I hope that this has been informative and hopefully maybe inspirational.